So we're going to do a little bit more sort of advanced family exploration site where we are going to talk about making the different parts of your family move together in unison in a predictable way. Now, what I'm going to start here with is a window. Let me just see here. I'm going to go on and grab the stuff from our BCIT folder. So each night, remember to get the, on the share out drive, grab each night's folder and copy it. So here I'm going to go to the BLDG 2805 folder for tonight and copy it to my desktop, so I've got it ready to go. Okay, so what we're going to talk about here are constraints. Now, what a constraint is, it means when something is locked to something else inside a family, and that's what we'll mostly be talking about tonight is with families, but you've probably seen it in projects too. So let's just look at an example, a very simple example of what a constraint means. Now, the most common one is a locking constraint. So if you have a building, so here I'm just going to throw down some walls just to talk about the concept. You can have two walls with a gap in between that, using the align tool, you can lock them to each other. So if I've got two walls that have different alignments, and then I use the align tool with the with lock turned on. So here I pick the one wall and then I pick the other, and I lock them together. That's called a constraint. And what happens now is that if one wall moves, the other wall moves with it. You guys have used that before. Another constraint that you've probably used is the equality constraint. So you've got a number of objects that you've put in place, and then when you put a dimension between them, so this is a multi-string dimension, right? So you've got multiple dimensions in the string. They're not the same spacing. But after I've placed the dimension, I can make the value equal, and now they are constrained. So that's an equality constraint. So you can have an alignment constraint, or you can have equality constraints, and we'll talk about some of the other ones too. So it's basically maintaining a relationship between two different pieces of geometry in what you're building in Revit. Now, what we're going to look at first of all here are two different windows that you folks should be able to find in the Session 6 folder. And I am going to open them both up right now. So I'll start with the 313 light with mid-vent. The 313, by the way, what that refers to, if you look in your handouts, you can see that the window has three columns of glass. The first column has three lights. The second column has one light. The third column has three lights in it as well. So that's why it's 313. So there is this one window, the 313 light with mid-vent. So we're going to contrast how this window has been organized versus the next one here, 313 light with mid-vent reference planes. So I've got two copies of the same model, and what I'm going to do here is I'll just tile the windows so we can see them side by each. And you can do that by going to the View tab and then choosing Tile. So I can see these two windows side by side. Now, what you might notice is that the one that's called ref planes has a lot more reference planes in it. So here you can see when we zoom in and we look at the same part of the window for each of them, you can see that this one here has reference planes on either side of the window frame on the inside, and this one doesn't. So we're going to talk about the rationale between these two windows, which create exactly the same look of the window, and they behave exactly the same way. It's just that one of them, I used more reference planes to build it, and I will explain why in a moment. Now, let's look at how you build something like this in the first place. So when you're building your own windows, I'm just going to turn on shading here so that it's a little easier to see. So you see I've got a black window frame, and I've got basically a decorative concrete lintel above and below the window. This particular window, when we put it in the project, we wanted to have this sort of fake appearance of a concrete lintel and sill below it, so we had that added. Now, so for the rest of the window, pretty much standard issue. Now have a look at the notes here and talk about how this whole notion of going from the outside to the inside. Now, most of the time you folks will need to build your own windows and doors. That's kind of the sorts of things that you want to build most frequently when you're designing a building. Now, when you start building a new window from scratch here, so I'm just going to go to File, hover over New, and hover over Family here. Don't worry about doing this yourself, just watch what I'm going to do here. So when you start building a window, you've got the opening here and the piece of host wall, and you build the window inside that opening. So look at your notes here. So you start from the outside, so you make the frame so that it first of all follows the size of the opening. So if your opening gets larger or smaller, overall you want your window to stay and keep up to date with the change in size of the opening. So that's the first part. Then you've got your inside window frames, and those need to adjust their size along with the opening. So that will be sort of the next step in terms of building the windows, that we will create the frame. After we create the frame, then we will create the glass. So here you can see we've got glass for the non-operable parts of the window, so that gets created next. Then we have to put in an operable vent. So we're working our way from the outside to the inside. So fixed glass, then the vent, and then the glass inside the vent. So there's those different steps of going from outside to inside. If you're doing something like a door, you would model the frame of the door, then the leaf of the door, and then if you wanted to put glass inside the door, that would come after the door had been, after you've modeled the door. And that's just in a series of minutes. We're not talking a long time afterwards. We're just talking the step-by-step process. So let me go back here to the window here. So I'm just going to select these extrusions on the 313 light with the mid vent. So there's our frame on the outside. You can see the different components of the extrusion. So that's the first step, getting that all ready and dimensioned so that we have dimension parameters that can edit the size of the window and the width of the frame. Then after the frame is done, so I'm just tab selecting here to get the glass. So there's the glass there. And if I edit extrusion, you can see the pink lines of the glass. Now you will notice there's no dimensions here. And if you guys took the intro course, you'll remember that to grate the glass for the inside of my window, we just used the pick tool. There's no dimensions required. Pick and lock. And we just pick the inside edges of our window frame, and that defines where the glass stops. We're going to do this ourselves, so you don't have to worry about it. So just laying the groundwork here so that you can repeat this process later, which we will do step by step. So there's your fixed glass. Now next I mentioned we have a frame, so that's this guy right here. And when I edit it, you can see that there's dimensions there that help drive the width of our frame for the operable vent. So that's done. Then we've got a piece of glass inside the vent, which I'm tab selecting here. There it is. And just like the glass that's fixed, the glass that's in the vent, no dimensions on it either, because these sketch lines for the glass inside the vent use the inside edge of the frame of the vent to locate where the glass stops. So as my event frame gets larger and smaller, my glass stretches to suit. So it's that whole inside to, or outside to in, that's driving this process. Now we're going to go back and talk about the two ways that you can construct your windows and doors. Now this one here is a rather minimal approach, which I like to use. And when I say minimal, what I mean is fewer reference planes. So here's the one that has more reference planes, and here's the one that has less. Now, let's look in the 313 light with the mid-vent. I'm going to edit that extrusion. Now you'll notice that within this sketch of the extrusion, that all of these dimensions here that control the width of the frame are inside the extrusion. So I've clicked on extrusion, I've edited it, and now I've added dimensions. Well, you can see the pink lines of the extrusion. This is nice on the one hand because visually it makes the window, while you're editing it, cleaner. There are fewer reference planes, and to my thinking, it's a little less confusing to build this geometry. Now, with the other window here, the one that says 313 light with the reference planes, what I've done is I've added a reference plane that would be needed for each side of the mullion, and all the dimensioning for it has been done before the extrusion is even drawn. So that means when I came back to do this extrusion for my window frame, what I did was I had no lines here, but I used the pick tool, and I picked the reference plane on all four sides, 1, 2, 3, and 4. And then of course I had to use the trim tool to make this a square, or a rectangle rather. Now you might look at this and go, well, that doesn't look any easier. Well, it is in one respect. It means that all of my geometry can link itself back to these reference planes. In the other example here, inside my extrusion, I had to put all the dimensions inside here, and you'll notice that on one side I've got dimensions, and on the other side I don't. So the upshot of this is that if this parameter value changes, so if I change my interior mullion width to be a different number, this side has dimensions on it, so it's going to change. But what happens on this side? Might not change. Well, it will if we use the align tool. And if you folks were in the intro class, I'd show you how we, inside the sketch, we'd pick the sketch line on this side and then pick the sketch line on the other side, click it, and you'd see a little lock icon here, and we'd lock it. It's already been done in this case. So these two sketch lines here, these two pink guys, are using the align tool. They've been aligned to these two sketch lines on the left that have the dimensions on them. So I had to do that here and here and here as well. So it was a little bit of work to set up that initial extrusion. But once that's done, no other reference planes required. So when I get finished, then I don't see those other reference planes in my view. It's up to you which method you want to use. So the advantage of this one is that it's a little bit cleaner. The advantage of this one is that you don't have to be as careful with the use of the align tool when you're locking one set of mullion lines to the other set of mullion lines. Okay, now let's get into, let's go to page 2 here. So we're going to talk about the different kinds of constraints. Now, why don't we get started on doing this constraining work, and we will start with, let's going to see what the first exercise we're going to work on here is. Yeah, no, we'll just start with a window template just to get started. So go to the File menu and hover over New, and then choose Family. And then you can choose Window out of the list. Now, how many of you haven't been to the intro course? So you haven't taken the intro course and you haven't had the chance to build the window family. I think there's like a couple of you in this course. You're hiding because you're frightened. Don't be frightened, it's okay. A lot of people crash this course because they have used Revit for a while. We're just going to do one thing here, folks. Go to the plan view of this new window template and find the reference plane tool and draw one reference plane across from one side of the window to the other. It doesn't really matter where you draw it. It just needs to be somewhere within the depth or the thickness of the wall. Now, what I'm going to do here is I'm going to click the name here and change it to face of frame. Now what we're going to do is we're just going to create the one extrusion so we can talk about constraints. Okay, so I'm now going to double click the exterior elevation view here, and you might have to hit ZX to get everything to fit in your view. So once you've gone to the exterior elevation, just hit ZX on your keyboard to get things brought into view. Now, because we named that reference plane, now we can go to the Create tab. And way over on the right hand side, we will find the Set Work Plane tool. And here we will choose out of the list here that the Set Work Plane dialog box shows us. You'll see that reference plane you've just named, so you can go ahead and choose that and hit OK. Now, what we're going to talk about here is constraining. So start the extrusion tool up on the ribbon. And now what we're going to do is we're going to use the pick tool. Now, just pick the top edge of the window and you'll see that a lock icon appears. So use pick with lock. If you forgot to hit lock, hit the padlock icon when you see it to lock it. So this is a constraint. Now, what we're going to do is draw the three other lines like this. We're not going to draw them at the opening. We're just going to draw them inside the opening because we're going to use the Align tool to put them into place. So now what we're going to do is use the Align command, the Align tool up here on the ribbon, and pick the reference plane on the left-hand side, and then pick the left sketch line and lock it. So you've created a constraint. So that is called an edge constraint. So that's where you constrain a line of geometry inside one of the solids that you're building, and you're aligning it to the edge of something else in the file. So we had an edge constraint that we did already. This is an align constraint. It does the same thing. There's no difference between an edge constraint and an align constraint at the end. They both create the same function. So again at the bottom, and locking it, and at the side again and locking it. So that is an alignment constraint. Now let's look bottom of page 2 here, second last bullet point, center constrained. Now, a center constraint is where we use an EQ dimension with two different pieces of geometry. So folks, grab the pick tool and in the offset box put in 1 inch. And what we're going to do is, using the pick tool with a 1 inch offset, you're going to create two lines around this center line. So there's one and there's the other. You're going to have two lines. center constraints are very useful to allow you to have geometry that stays centered on a particular divisor in your family. So typically your reference planes will help to break your window up into different parts. So if you've got, like in our 313 window, we've got 3 lights on the sides. So we have 2 horizontal reference planes to help break up the window into those different parts. Now here, this would allow us to have a center frame and glass on either side. Now to keep these sketch lines that we've just placed centered on this reference plane, we use the dimension command. So use the dimension command, go from sketch line to reference plane to sketch line, find some white space and place it. You'll see the EQ button down below, and there you are. That is an equality constraint. You bet. So start with the dimension command, pink line, reference plane, pink line, white space, EQ. So what this means is that once we've finished making this window frame, as that center reference plane moves from side to side, these lines that would be part of our window frame would move with it. So that is a center constraint. Now, the constrained to a point. Now, this maybe just go back and talk about how Revit likes to place dimensions. Now, when you place a dimension in AutoCAD, you can just click on a point and go to another point, and you'll get the endpoint snap, and AutoCAD will create those dimensions. And Revit does that too now a little bit. See, I can go from this point to this point here, and Revit will create a dimension between them. In successive releases of Revit, Revit's been a lot more willing to do that without you having to go through too many gyrations. It used to be before, with older versions of Revit, you had to hover and hit the tab key a few times until you got a tiny little blue pixel dot appeared on the end of the line, and you'd know you could snap to it. Now Revit's making a nice little blob there that you can see fairly readily. So now what we'll talk about is constraining to a point. What we're going to do here is we'll just, on the Modify tab here, let's just add some more lines, and we're going to not create parallel frames for our window here. You might be thinking, what in the world? Just bear with me here. So something along those lines. Just draw a polygon inside the frame. So bottom of page 2, we're talking constraining to a point. Now what this means is that this vertex here, where these 2 lines intersect, we can run a dimension from a reference line to that point. Or you can do it in the other order. You can click the point and then go to a reference plane, and it will create a dimension between it. So what this means now is that we can control the distance between this vertex and this reference plane. So when you're not making parallel geometry and you need to do something that's a little bit sort of more tectonic in its shape, this allows you then to constrain the points, the vertices of what you're drawing, and tie them back to some other reference plane in your family so that you can now control the size of this polygon. Okay, let's go to page 3 in the notes here. So we'll just talk about circular constraints. Now, just so we can make this a valid bit of geometry here, we will clean this up. So this, of course, is not going to work. If I want to have this frame here in the middle, and I want my window frame, my irregular window frame, for this to finish. Revit's not going to like that. So we've got intersection problems here. So what we have to do is two things. You have to use the split tool, and we're going to split this line along the top here in half, and same at the bottom. That's the first thing we've got to do. Second thing, we use trim. And that's why we split these things into two parts, so we could, it's like fillet. So now this is a valid frame as far as Revit is concerned. Now, constraining circles. We're going to be making some wine tanks for the winery. So what we want to be able to do is to control the size of the circle, and we want to be able to control where it is located. Now, just to show you folks how this is going to work, you can stay inside your window frame sketch right now. Grab the circle tool. Grab the circle tool, and we are going to draw a circle just up here off the edge of the wall. Doesn't matter what size. Now, if you want to be able to move this circle into a different location within your family, you can do it using a couple of different options. So once that circle is placed, folks, grab the dimension command again. And what we're going to do is show that you can dimension. So here, if we're starting from this vertical reference plane, if we pick one of the quadrants that's closest or farthest away from the starting point, we can dimension to that location. We also can dimension to the center of the circle instead. So I'm just undoing those last two steps. And now I'm dimensioning from the reference plane, and if I put my cursor sort of at the other quadrant, so if I put it at the close quadrant or the far quadrant, it dimensions to those quadrants. But if I put my cursor somewhere other than that, you can see it's going to dimension to the center of the circle. So you can dimension either to near and far quadrants or to the center of a circle. So there's dimensioning to the center, or dimensioning to the near side quadrant, or the far side quadrant. So that allows us to locate this circle from those reference planes as we wish. Now, if we wanted to make this circle able to move, we would, of course, select our dimensions and then add parameters for them. We're going to be doing a bit of that later. We won't worry about that now. With respect to altering the radius or diameter of our circle, there are dimension commands for that. So you can decide whether you want to do a radial dimension or a diameter. And of course, after you've placed that diameter dimension, if you want to make it parametric so that the user can change the radius or the diameter of that circle, easy to do. Click on the dimension after you've placed it and go find the Add Parameter button and give it a name of some kind so you'd know what it's for. Okay, moving on to arcs here. Bottom of page 3. So I'm just going to delete the circle here. Now, if you need to make a round-topped door or a round-topped window, the first thing you need to do is to alter the opening. So I'm just going to finish this, and you folks can do it as well if your extrusion is complete. So what I've still got is I've got a rectangular window. But what if I want to make a round-topped window? Well, first of all, we need to make sure the opening does the same thing. So finish your extrusion, and then we'll go and talk about the process. So going from the outside in on a family means, first of all, if you're not going to have a simple rectangular opening, you need to modify the opening. Now we showed you last week how you can do that with voids. Today we're going to do that just by modifying the opening object. So in your elevation view, exterior elevation, put your cursor over where you know the edge of the opening to exist. Hit the tab key once, twice, and there it is. You can see on the cursor, or on the status bar rather, at the bottom it says opening cut. So now when I left click, I have that opening selected, and you folks can see up on the ribbon I can choose Edit Sketch. So again, go to the exterior elevation, hover over the edge of the window, 2 tabs, 1, 2, or however many it takes until you get to the opening cut. Watch for it on the status bar at the bottom. Left click it and Edit Sketch. So if I was going to make a round topped window, before I even started making the frame, the first thing I would have done was edit the opening and put in an arc. So here I'm using a 3-point arc, and with the 3-point arc you draw the start, the end, and then you come back and choose a radius. You do the start, you do the end, and then you choose the amount of curvature you want for the last point. So now we can talk about how you can constrain an arc. Because arcs have endpoints, they will tend to be quite sticky to the next part of the object that you draw. Typically we don't draw an arc that's just sitting by itself. It's usually part of the geometry of an object, so there's other lines and segments that are being drawn to create this window. So the endpoints of the arc, they're going to stay stuck to these corners. You won't have to worry about that. Now if you want to be able to change the height of the arc, you can simply grab the aligned dimension and go from the top of the window up to the apex of the arc and put a dimension on it. So let's say that regardless of the width of your curved top windows, you wanted to have 6 inches of height curvature, right? So when you look at the windows down the side of the building, the curves all go up to the same height. They'd all have different radii, but that doesn't matter. We'd probably want them to all have the same amount of height in their curvature. So what we could do then is specify, make it parametric. So here on this dimension that I've got to control the height, click it once, go up to our create parameter button here, and I'll call this arc height. So now the user would be able to change the height of the opening because it'll be a parameter in the family from now on. So that's the opening. Now of course the next thing we'd have to do is alter our window frame. So click on your extrusion and edit it, and we'd simply delete this line here at the top of the window and use the pick tool with lock enabled, and so now our window frame is going to be locked to the opening. So once our opening is done, you click on your extrusion, edit it, delete the top segment, and use the pick tool, make sure it's locked, and lock it to the opening. So again, outside to in. So if you've got a special opening size you want to make, so one of the examples is like a door with a side light. So if you've got a side light outside the edge of your door, you'd put another reference plane in for that side light, and edit the opening to also include the opening required for the side light beside your door. So when I was making the opening here, right? So once I've made it parametric, you can slow double click on it. 1, 2. And you can change its value here. Once you've got parameters on your family, of course you can go into the family types dialog box and you can change the values in here as well. But you can also change them directly if you can see them out in the view. Okay, so that is constraining an arc. Now before we move on too much farther here, just a note about solids and voids. Now, if you create a solid first and then add a void, the void will cut the solid automatically. So right now, folks, go to the Create tab and you'll see from the Void Forms drop-down that you've got all of the different void creation tools as you had with your solids. So here, what I'm going to do is I'm going to create a void extrusion, and I'm just going to make it as a long rectangle like so. Now, because the void is created after our window frame, chronologically, when we're done, you can see that the void automatically cuts our window and hides itself. If a void doesn't have anything to cut, it will appear orange. But the instance that this void gets an opportunity to cut something, it will hide itself. Now, what happens is the void is created first, and then we put a solid in the same location. So back to Create, back to Extrusion. Again, I'll just draw a little rectangle right in the same area as my void. Doesn't cut it. So solids that are created chronologically after voids will not automatically be cut by them. Now you can control how voids interact with solids regardless of the order in which they were created by using the Cut tool up here on the ribbon. Now we've talked a fair amount about the Join Geometry tool in terms of walls joining other walls and walls joining floors. Now with the Cut tool I can say don't cut something. So this void I've just created right now, if I choose Uncut Geometry, doesn't matter which order you do it in, you can pick the solid and then the void, or you can pick the void first and then the solid. So now this void isn't cutting that solid. Now conversely, there is a Cut Geometry tool. And now I can say, Mr. Void, please cut this solid. So the Cut Geometry tool will give you a little bit more control about how your solids and voids can interact with each other. Unlike a solid, which you can choose to make visible or not. Now we've talked a little bit about the visibility settings dialog box here and how you can set certain geometry to be hidden in plan, like a 3D door leaf. Also, what we have with our solids in the properties palette is we have this visibility checkbox. So this allows us, if we want, to be able to hide some parts of our family. So to give you an example, I'm going to go back to the 313 light. Remember these fake decorative concrete things at the top? We have a visibility parameter, and what we did is we hit the little gray box at the side so we could control whether those fake lintels and sills show up in the project when we use this family. So what these becomes little check boxes when user is putting these windows into his project, and if he unchecks head trim visible, it doesn't appear. So solids, you can do that. However, voids, you'll see here, there's no such control. Now, in a sense, it doesn't make sense to make a void invisible because they kind of already are invisible. But wouldn't it be nice if I could say, hey, you know what, Mr. Void, I don't want you to cut anything right now. Don't cut. Unfortunately, you can't do that. So one of the Revit users, I don't know who to thank for this, came up with a really novel idea. And if you folks look at the glulam with end cuts, this is the standard Revit glulam beam family that we used to build that gazebo thing in week 3. This is it right here, real short version of it, mind you. But if we go to one of the elevation views of it here, front elevation, there are 2 voids right there. You can see them. Turn on the color. There's one void, there's the other. Now sometimes, based on the look that you want for your building, when you push those beams out into the eaves, you may decide that you don't want to cut out the bottoms of the beams, just for architectural reasons. So how can I get this beam so that the void no longer cuts inside our beam? Well, the answer is by moving it out of the way. So look what we've done. The void is constrained to a reference plane, and we have a parameter that moves the void out on its own reference plane away from the solid so it can't cut it. That's the answer. If you folks ever have need of something like that, or you want to have a little bit more input on how this family was created, but that's how it works. So if you want to avoid to not interact with one of the solids in your family in the future, you can't just uncut, or you can't create a don't cut or uncut geometry parameter inside your family. You can't. You just got to move it out of the way. So if it happens to be close to the beam, it'll cut it. So it's going to cut the beam unless you just simply move it away. So by dimensionally moving those voids out, it means they no longer cut any solids. So that's all I want to talk about on page 3. Let's take a break for 10 minutes, and then we'll come back and carry on.